Hey guys, this is Carrie, and this is the answer key video for homework number 11. So we continue to work with trig waves. On the grid below, graph the function -3 sine x plus 1, so vertical shift of 1, which raises our midline, on this domain. Make sure to label your key values on the x and y axes. So I'm going to take what Sam does and draw the midline out. I would do it dashed, and then I'm going to add the values for the x-axis, where we would usually have them on the midline. And so because we're including the negative values from our domain, we'll have to go back -pi/2, -pi, -3pi/2, and -2pi. All right, so now that we've got our axis set up, we need to sketch our curve. So since the amplitude is -3, we're going to be going between the midline and 3 below and 3 above, which would be -2, 5, and 1. All right, so drawing our curve, we've got a negative sine curve, which means it starts at the midline, goes down first, then up, up, and then down back to the midline. And so we've got the first period here, and to draw the negative side, we need to have the exact same shape going in the opposite direction. So we'll have, instead of going down first here, when we continue it, we'll go up, down, down, up. And so we have the exact same shape here and here duplicated. All right, so that's the end of problem 1. Graph one period of the wave whose equation is this. So this one's a little bit different because we have a more complex inside to our sine function. So when we graph it, we'll have to be careful about that. So we draw it out here. We've got 5. We've got -5. It's a sine function, so it starts at the midline. We'll have our 4 key values on the x-axis. So we go up, down, to the minimum, and back to the midline. Now, to figure out the tick marks here, we can't just put 2pi here, because having this value inside with x will change the period. So the way I like to do it is, to complete a full period, the inside of our function has to hit 2pi, which means that we'll solve for x from here. So we get pi x equals 12 pi, divide by pi on both sides, x equals 12. So we get 12, 6, 3, and 9, and we're done. All right, so now to determine the equation of this graph, we're going to be doing the opposite. Instead of going from an equation to a graph, we're going to be going from a graph to an equation. So let's do it. We've got y equals amplitude 3 cosine, and because the period of this function is pi, we know that we're going to need a more complex inside, not just x, because that would make it 2pi instead. So what we're going to do now to find that b value is we're going to say when we plug in b on the x-axis, when we plug in pi on the x-axis, then the inside completes a full cycle. So the inside becomes 2pi. So solving for b, we divide by pi on both sides, and we get b must be 2. So the final answer for this equation is y equals 3 cosine 2x. Now we'll do this one. This one has a little trick to it, which is instead of showing 1 period, it shows 3 periods, and a number of people have a number of different ways for doing this. I think Victoria had a cool way of doing it in class today, where she looked at all 3 periods together. For me, I like to look at a single period of the graph. So a single period of the graph, if we want to put the x values, because 3 of them make 24, if we take 24 and we divide it into 3 equal pieces, we get 8. So 1 period will be 8, 2 periods will be 16, 3 periods will be 24. But the way I solve these problems, I don't care about 16 and I don't care about 24. I only worry about 1 period. And now, just focusing on this part of the graph, it's almost like I was given an equivalent problem to the one that we were given here, because this is just 1 period shown. All right, so we have y equals 5 sine got to have a complicated inside for our function bx, and we have to solve for b. So when we plug in 8 for x, the inside has to complete a full cycle. So we divide by 8 on both sides, and we get b is equal to pi over 4 after reducing that fraction. So we get y equals 5 sine pi over 4 x. Final answer. Determine the equation of the graph shown below. So I'm going to leave this one for you guys. Sorry, that was supposed to be dot, dot, dot. And I'm going to do just the last question, because I think that if you understand this one, you'll understand everything. So I like to sketch in the midline here, because that is important. Now, instead of being shown 1 period, we're shown 2 periods, so I break it down in half. If this is 20, that means that 1 period is 10. So now I focus only on a single period of the graph. From here, we see that the equation must be y equals amplitude is 2, because the displacement from the midline is 2 in either direction. It's going to be a sine graph, but because the graph goes down and then up, it's the reverse of what we expect, so it'll be negative 2 sine. And then we need a more complex inside function than we usually have, because our period is not just the standard 2 pi. Finally, the whole graph has been shifted up 5 units, which means that we have to have an exterior plus 5 for the vertical translation. So when we plug in 10 to the inside for x, what should happen is it should complete a full cycle, 2 pi. So we divide by 10 on both sides, and we find that b is equal to pi over 5 when we reduce it. So the final answer is y equals negative 2 sine pi over 5x plus 5. All right, guys, I hope this was helpful, and I'll see you in class on, well, tomorrow, because for each class it will be different. Bye, guys.